In this video, we're going to take a brief overview of a really interesting paper called Curvilinear Motion in the Absence of External Forces, Naive Beliefs about the Motion of Objects. So this is a bit of a mouthful, but what this paper is really looking at is, in general, the issue of intuitive physics and the idea of mental simulation. So I will provide some results from this study and also just read some select extracts. So the abstract reads, university students were asked to draw the path a moving object would follow in several different situations. Over half the students, including many who had taken physics courses, evidenced striking misconceptions about the motion of objects. In particular, many students believed that even in the absence of external forces, objects would move in curved paths. So, in this paper, there are some interesting points that can be extracted in order to really capture the essence of it. Normal experience should be sufficient for a basic understanding of many simple mechanical principles. However, several experiments that we recently conducted with university students suggest that this is not the case. So you can already get the idea here that the tasks that the students were asked to perform, they didn't really do very well at them. The experiments are part of a larger project that seeks to characterize internal representations of the physical world in people with various degrees of expertise in physics. The results clearly indicate that many students who have completed one or more physics courses, as well as many of those without formal instruction, fail to understand the most fundamental principles of mechanics. So this sounds not good in terms of how well these students performed. So let's have a look at the kind of tasks that they were asked to perform. This is a really nice figure from the paper. This shows 4 example problems. Now there were 13 sample problems, and it's a bit of a shame that we couldn't see all of them in the paper. But what we can see here is that these 4 problems involved kind of motion of various sorts. So the students were told that some kind of metal ball was pushed down a pipe. So this was the case for problem 1, 2, and 3. So the ball was pushed down the pipe, and they were basically asked to draw with a pen or pencil the trajectory that the ball would take once it left the pipe. Problem 3 is only marginally more complicated because here we have 2 balls being pushed through pipes which come to kind of meet together. Problem 4 is slightly different. So here we have a weight which is represented by the black dot, and this weight is basically being spun from a string at the center of this circle. And so the circle represents the path that the weight is taking. And so the question would be, if the spring were to break, if the ball were to come off of the string, trace out the path that the ball or the weight would take. Now, what do? So this is a really interesting depiction of the results. So I guess what they are doing here, in the left and the right columns, they're kind of presenting the correct answer and an example of the wrong answer. So in the first example, about 2/3 of people were able to correctly say that the ball would go out in a straight line from this tube, but a full third of people seemed to believe that the ball might continue in some kind of curved path. Similar findings were shown in problem 2, and if you think about it, problem 2 is kind of related to problem 1. The pipe here has kind of more curvature, if you like. So it's kind of interesting that actually now we have roughly 50-50 people thinking that the ball might go straight, but we're having a higher proportion of people thinking that the ball has somehow kind of inherited some inherent curvature, and so it would take this curved path. A similar type of thing happens with problem 3. The correct answer is that the balls will continue on in a straight line trajectory, but about 30% of people think that somehow the ball will take this kind of curved path. Just to say, in all cases, we are looking down upon the tube and the ball being pushed through them, and so there's no real role for gravity, just to clarify that. So they say, these results suggest that many people believe that when an object is passed through a curved tube, it will continue in a curved motion even when no external forces act on it. What about the last problem? So up the top left here we have the correct answer. So again, this is a ball being rotated on a string, and people are asked to trace out the curve, the line that the object may take. So 53% of people managed to get it right. It's essentially that it would go in a straight line in a kind of with whatever velocity it had at the last point. So it would just go in this straight line here. But there are a couple of different types of incorrect answers. So the most common type was, again, to think that the path would take this curved shape. But we have at the bottom of this figure two kind of rarer types of mistakes, but which were actually based upon physical principles. So afterwards, when they were asked in an interview why they answered in this way, one person was thinking about centrifugal forces and thought that the string was kind of holding the ball from spiraling outwards in a way, and so if the cord was cut, then the ball would just go straight outwards from the center, and that's incorrect. Another kind of interesting incorrect answer is essentially hedging your bets between that last incorrect one, that the ball would spiral out or just project outwards from the center, and the correct answer. So J could be kind of panel J here could be thought of as an interesting type of incorrect answer.